turbulence spills around the edges. Winds here travel at more than 250 miles per hour.
It's true that it has a lot of similarities with hurricanes in that the outer edges, it's swirling around a lot faster. And so indeed the inner parts are more calm.
At first glance, the red spot looks similar to hurricanes. But there is a difference. Here on Earth, hurricanes feed off the warm waters of the ocean. But as soon as they hit land, they start to die. Our storms only last about 2 weeks. But Jupiter's different. The red spot has been raging for over 300 years.
The reason why we last such a long time is there isn't a surface on Jupiter. So it's not as if storms run into a continent and dump its energy. It just keeps going and going and going around and around.
But the spinning of Jupiter is not enough on its own to drive the Great Red Spot. Scientists discovered the planet gives out twice as much energy as it receives from the sun, suggesting its core must be hot. This center could be the powerhouse that drives Jupiter's winds. The core could be worth a closer look. As we descend through upper layers, vast water clouds envelop our craft. The pressure is climbing. Toward the center, it transforms the hydrogen atmosphere to a strange liquefied metal, resembling the element mercury. This is the core, a churning furnace at over 40,000 degrees Fahrenheit. Scientists estimate that the pressure here is 100 million times higher than on the surface of Earth.
How can I give you a sense of what that feels like as a pressure? Well, if anyone's had someone step on their toe with a stiletto heel, you know that's a lot of pressure. Now imagine an elephant wearing stiletto heels and standing on one foot on a stiletto heel. But to get the pressure at the center of Jupiter, you need to have about 1,000 elephants standing on top of each other, the bottom one on one foot on a stiletto heel.
At these sorts of pressures, humans could never journey to the core. But could we survive in the upper atmosphere? The answer to that lies on one of its moons, which has an extraordinary effect on the gas giant. It might be dwarfed by Jupiter, but this minuscule world packs a mighty punch. Our quest for a new home has brought us a long way. We are 365 million miles from Earth, in orbit around the giant planet Jupiter. Could we survive here? Perhaps in the turbulent upper atmosphere? That depends on what's happening around us. On Jupiter, that means looking at its moons. Io is tiny, but it's the most volcanic body in our solar system. And living next to a volcano is never a good idea. Dr. Rosalie Lopez is a volcanologist. She's come to the Kilauea volcano range in Hawaii, one of the closest matches on Earth to Io's fiery surface.
This is very much what the surface of Io may look like, particularly close to the lava flows. There would be lava flows just like this, solid at the surface with underneath us hot lava flowing.
Like Kilauea, Io spews lava from its superheated interior. But that's where the similarities stop.
The volume of lava that Io's volcanoes erupt is quite staggering. If we do a comparison with Kilauea, in 5 months, Kilauea might cover 4 square miles. But Io erupts about 100 times the volume of lava. One lava flow on Io covered 240 square miles.
On Kilauea, the heat to drive the volcanoes mostly comes from the decay of radioactive materials deep in the Earth's interior. But on Io, The activity is generated by something entirely different: tidal heating. Just as the oceans of the Earth rise and fall with the pull of our own moon, so Io's surface distorts with the gravity of Jupiter and 2 nearby moons. The ground rises and falls by over 300 feet, the height of the Statue of Liberty, every 2 days. Its pulsating surface creates enormous amounts of friction deep inside the crust. Heat and pressure build, turning solid rock to molten lava, forming lakes the size of Arizona. Io's volcanoes are deadly, but they aren't the real killer. Before the lava can get you, the radiation will. Just 10 minutes on the surface, and you're toast. Even over 200,000 miles away, in Jupiter's upper atmosphere, an unprotected human could only survive a matter of hours. The volcanic particles that Io blasts out into space become trapped in Jupiter's enormous magnetic field. Jupiter's rapid rotation accelerates them to fantastic speeds. They're like microscopic cannonballs. They form a radiation belt around Jupiter, cutting through almost anything in their path.
They're sufficiently intense that a human would receive a lethal dosage within just 10 minutes. So you couldn't just fly through the system and survive, you would fry up. This intense bombardment would destroy your flesh and the organs inside, everything.
We just don't have the technology to protect ourselves from radiation this fierce. Jupiter is one planet we'll never call home. Could our next stop offer more hope? Saturn's radiation levels are lower, but it's not a danger-free zone. From Earth, Saturn appears almost featureless, but its appearance is misleading. Its rings may look solid, but in fact, they're mostly made up of billions of chunks of ice and rocks, ranging in size from pebbles to blocks as big as a car. All of them are moving faster than a high-speed bullet. But Saturn's real danger lies within its atmosphere. Like Jupiter, the planet has bands of high-speed counter-rotating winds. Clouds race around the planet at over 1,000 miles per hour. Along the edges where two bands meet, tiny particles collide, brushing past each other, generating an enormous electrical charge. Theory suggests that when the charge gets too great, the electricity arcs between the clouds, producing giant lightning bolts. NASA's Dr. Kevin Grazier is a planetary scientist who specializes in atmospheric conditions on Saturn.
We have a chance for a lot of charge transfer between one band and the other, creating large voltages, creating huge lightning bolts.
To get an idea of just how huge Saturn's bolts are, compare them with Earth. Lightning here can hit 50,000 degrees Fahrenheit in a split second. Striking the ground, it's hot enough to create a tube of solid glass, stretching down 15 feet. But compared to Saturn, that's a tiny spark. A single storm on this gas giant can cover the whole of America.
And you can also get storms that last for years.